Hi, in today's tutorial we are going to learn how to classify dinosaur images. So we will download a dataset of several thousands of images that are being classified to several categories, and we will learn how to prepare the data and create a model in order to classify those images. Then we will take these two fresh images that were downloaded from Google, and we will use our model to predict these new fresh images. So let's start coding. The first process, of course, will be download the dataset. So let's go to Google, and in Google let's go to the Kaggle website. Okay. And then we are going to search for our dinosaur dataset. It's called simple dinosaur dataset. Here it is. As you can see, in this dataset we have 5 categories. I will not try to pronounce them. It's too difficult for me, but as you can see, there are many images for each categories. As you can see, for this category there are about 40 images, and I believe that the amount of images is similar for each of these categories. So let's download this dataset. I will not waste on time on extracting the zip file, so I'll already download it and open a folder with those images. As you can see, I'm browsing these images. This is, for example, the first category. Let's go for another category called T-Rex. It's a T-Rex, of course. So as you can see, there are many images of T-Rexes in many shapes and in many backgrounds. So as our dataset is downloaded, let's start coding. Let's create the first Python file. We will call it build our model. In this Python file I will prepare the dataset as well. Okay, as you can see, I've left a link for the Kaggle dataset that has 5 classes of dinosaurs. So now we are ready to start coding. So let's import NumPy and let's import OpenCV, and we will also import OS. This is the path for our images. You can store it whatever you like. I store it on my E dataset, simple dinosaur dataset folder. So first of all, let's create a categories variable, and in this variable we are going to import the names of the folders, which will be all our categories. And let's create another variable which will be the number of classes. Of course, it will have the value of 5. So let's run it. As you can see, we have a list of the categories and the value of 5. Of course, this was a straightforward process. Now let's create a variable for the batch size, which would be 32, and all the images would be converted to this size of 224 by 234. Now let's prepare our data. So we will use the Keras processing image and the image data generator in order to load the images and resize them to our model. So first, let's create a data generator, and each of the images will be rescaled between 0 and 1, and we will create a validation split of 0.2. That means that 80% will be for train and 20% will be for the validation data. So next, let's create our train dataset. So we will use the flow from directory function, and in this function we will send several arguments. First of all, our batch size, which would be 32, the path for our images, the color mode, of course, it's an RGB, since it's color images. We will shuffle all the images, and the target size would be our image size, which is 224 by 224, and very important, the subset would be training. Now we are creating the validation data set, and please notice that we are changing the subset to validation. Okay, so after this process, all the data was loaded to these two variables. So let's extract the first batch. Each batch would be 32 images. So we are creating two variables, batch X and batch Y. The batch X will be 32 images, and the batch Y would be 32 categories, or basically labels for each of the 32 images. So let's print the shape. So we should see in the first print 32 by 24 by 24 by 3. This would be the shape of the first one. And for the second printed value, as you can see, it's 32 by 5. So now we are ready for creating our model. So of course it will be a sequential model. So let's import the sequential from Keras, and let's also import the layers. We will use the conf d2 and the max pooling. We will use also a dropout to reduce overfitting, and the flat and the dense, we will mention it later. In the next phase. So first of all, we will create our model variable, and we will add the first layer of convolutional 2D. We will start with 16 filters, and all the rest will be a kernel size by 3 by 3, and activation ReLU, and the input shade of our images. Then we will add another layer of a max pooling with a pool size of 2 by 2. Now we will add a dropout of 0.5. That means half of the neurons will be it's a dropout of the process, and this process is a regulation process in order to reduce overfitting. So next, let's create another convolution layer of 32 filters, and the next one will be a 64. I believe we should add another dropout, and the next process will be adding a flatten layer. And now we are ready to add our dense layer. So we will reduce all the neuron and create a standard neural network layer of 128 neurons, and the last layer will be our dense layer with 5 classes, and we will change the activation to a softmax since it's a categorical model. So let's see. As you can see, this is the summary of the model. We can see that we have 5 categories as our last layer. So we are ready to compile our model. The compiling process had several arguments. The first, of course, is a categorical argument for the loss. We will use the Adam optimizer, and the metrics will be accuracy. So we will cover in the training process the accuracy metrics. Now let's create 2 more variables. One would be the steps per epochs, which is dividing the number of samples with our batch size, and the validation step, which is the same, but we will divide the validation samples to our batch size. Okay, next. Let's create an early stop-in. So each time the model is improved during the training, we will save our model as improved one, or the best one will be stored. So the name of the best model will be named as dino.h5. Of course, you can choose your own name, and we will monitor the validation accuracy, and the most important variable is the most important argument is the save based only equals true. So this is the training part. We will use the Feit function and we will send all the relevant arguments. First one is the training set. Next, the steps per epochs, all the variables that we prepared already. The epochs, let's try 50 as the 50 epochs for the training. The validation data is our validation dataset. Validation steps we calculated earlier. And the callbacks is basically the process of saving the best model. Now we would like to display the results after the training, so we will use the matplot pyplot object. So we will create the result of the training will be stored in the history variable. So now we are extracting several data from this history variable. So we will extract the accuracy, the val accuracy, the lost, and the validation lost. Let's create another variable, which is the epochs for the graph, for the chart, which will be a value between 0 and 50. So it's a range of the length of our accuracy. The accuracy was extracted from our history variable. So now we are ready for the plotting. So let's use the RRR is for your red. We will display a line for the accuracy and another line with the blue color for the validation accuracy. So the red would be the training and the blue would be the validation accuracy. The X label will display the word epochs, and the Y label will be the accuracy. Let's also add a title, which is the train and validation accuracy. That would be the text. The legend will be drawn on the lower right of the chart, and the show function will draw the whole chart. And let's run the same on the loss process. So accordingly, I will replace the accuracy with the lost values. So let's run it. As you can see, I have a syntax error. The matrix, I have to fix it. Okay, the spelling was not correct. Let's run it again. So it's looking good. As you can see, the training is running. I ran it on a fast forward process, so you don't have to keep on waiting. Let's wait a few more seconds. As you can see, each time the validation accuracy is higher, the model is being stored. As you can see, this is the accuracy. It's very good results, and the loss is very good results as well. Good, so now let's test our model with a new fresh image. So first of all, let's see if our model was stored. Yes, it was saved, dino.h5. Next, we have two fresh images. I will upload these images along with the code to my GitHub. So we will try to predict these two new images. So let's create another Python file. So the target or the purpose of this Python code will be prediction of these two images. So we are importing Tensorflow as TF, importing OS in order to load the categories, and we also going to import two Keras function that can manipulate the images. We will use NumPy and OpenCV to display the result. So first of all, let's load our saved model, and we will print the summary of the model just to double check that it was loaded correctly. So this is the name of the file. Let's copy it exactly. Good. And now let's print the summary of the model. Okay, let's run it. We are expecting to see, for example, as the last layer, 5 categories of 5 neurons. As you can see, the last dance has 5 categories. Good. The same batch size. And let's load our 5 categories. The name of the folders. Let's copy it from our previous code. This is only relevant to get the name of these 5 categories, creating the same list. I think we can copy the same code. It will be quicker. Now let's create a function that will help us to prepare the image for our model. In this function, we will do several steps. We will send the path for the image, and first of all we would load the image and convert it to our shape, which is 224 by 224. Then the next process would be converted to a NumPy array. Then we will add another dimension. That means that the shape of this image result variable would be 1 by 224, 224, and 3, because we have 3 channels. Then we convert it to 255, so the values of the image will be between 0 and 1, and we will return the prepared image for the model. Now we are ready for the prediction. So let's copy the path for our first image. This is the path. And let's run our function. The result will be stored in the image for the model variable. Then we will run the predict function, send this prepared image. The batch size will be 32. So the result array will store the result of the prediction. Now we will get the highest value, let's say the highest indication for the highest value. It will be stored in the answers, and let's print it. So the value should be between 0 and 5, which is the predicted categories. Let's run it. we have a syntax error. Let's fix it. The slashes is in the wrong direction. The bet size also should be bet underscore size. And it's all in lowercase. Okay, let's run it again. As you can see, the result is 2. So 2 means that it's the third of third categories between 0 and 5. So let's print the text of this category. We will extract the text out of the categories list. Let's print it. And run it again. So now we can see what is category 2, which is predestined. So we have the name of the category. So basically our model predicts. Okay, so we have the text of the prediction, and now let's show our original image with the predicted text. So we will use OpenCV for this process. We will use the function putText. We will send the image, our predicted text. The position of the text will be 0 by 20. The chosen font. Dot .0 is the size of the font, and we will choose the color. So basically it's a straightforward process of OpenCV, and let's run it again. We're expecting to see the image with the text on the image. As you can see, this is the text. So we have the image, we have the predicted dinosaur, and basically it's working very nicely, very cool. So let's try it on the next image. We're replacing the name of the JPEG, and we are running it again. I hope you enjoyed this tutorial. Thank you very much. Bye bye.